Hello, Miss Flowers here again to teach you the day 6 video lesson. So we have focused on prisms, we have focused on cylinders, and now we are going to focus on pyramids for today, okay? More specifically, lateral area and surface area of pyramids. So, let's do the warm-up. How about this? Pause it so that you can try the warm-up by yourself. Challenge yourself a little bit, okay? Pause it. We've learned, it says, which of the following figures has a larger surface area? We've learned surface area of cylinders. We've learned surface area of triangular prisms, like B, right? So you can do this. Pause it, try it, and then keep watching to see if you did it right. Okay, so let's do the surface area of this cylinder. So remember, surface area for a cylinder is 2 pi RH plus 2 pi R squared, right? The lateral area is that first part plus the 2 pi R squared. So 2 pi, the radius now, this says the diameter is 11, right? So the radius would be 5.5. So 5.5. The height, remember, from base to base, the height of the cylinder is 16. I'm going to move this over because it's not going to fit. Plus 2 pi, the radius we said was 5.5 squared. Okay, so this part would become 5.5 times 16 times 2. This part would become 176 pi. This part would become 5.5 squared times 2. 60.5 pi. So when you add these, that is 236.5 pi, which the other one, right, it's a prism, it's not going to have pi in it, so we need to kind of put this to a decimal so it'll be easy to compare which one's bigger. So 236.5 pi is 742.99, rounded to the nearest hundredth. And we have feet squared. Okay, so we did the cylinder. Now let's do the prism. This one, so remember, so surface area of a prism would be the lateral area part, right? Perimeter of the base times the height of the prism plus 2 times the area of the base. So the base here, this is, and I didn't write this, let's write this first. This is a triangular prism. You know that because the two bases that are across from each other are both triangles, here and here, right? Because the bases are triangles, that would be called a triangular prism. Okay, so remember when I was doing these, I kind of would branch these off so we could see what each part was, right? The perimeter of the base are what I just outlined, right? The triangles. The perimeter, we can't say what that is yet because we know one side of the triangle is 8, the other side is 15, but we don't know that third side. So remember what you got to do. Pythagorean theorem. 8 squared plus 15 squared. And we don't know the hypotenuse, so we just let that be C. So this is 64 plus 225. This is 289 when you take the square root. Okay, so we got that part is 17. Therefore, right, since now we know all three sides of that triangle, we can say the perimeter is 8 plus 15 plus 17, and that's 40. So the perimeter is 40. The height, let me use a different color. The height of the whole entire prism, right? That's from base to base is 50. And then we have plus 2 times the area of the base. Remember, the area of a triangle is 1/2. The base of the triangle in here in this case would be 15. The height of that triangle is 8. So I want to remind you, because this is where people get kind of confused, whenever you're trying to find this capital B, right, the area of the base, then your mind has to switch to 2D. All the stuff we did last chapter, right? Finding the area of two-dimensional shapes. Because when you're finding the area of the base is a two-dimensional shape, right? It's just flat. So you kind of have to switch your mind from thinking 3D to 2D when you're doing that capital B part, okay? So anyways, this part, when you do 15 times 8 and divide that by 2, that's 60. Okay, so now we can plug everything in. We have the surface area would be 40 times 50 plus 2 times 60, right? The area of the base. I just took all those numbers from up above and put them into the formula. So this part is 2,000. This part is 120. So the surface area is 2,120 feet squared. Ooh. Okay, so we can see which one had the bigger surface area. Clearly, the triangular prism did. So I'm just going to circle it like this. Which of the following has the larger surface area? The triangular prism, right? Because that one had 2,120, the other one only had 742.99. Okay, hopefully that was a nice little review of surface area for those two shapes, because now we're going to learn lateral area and surface area for pyramids. So here's some vocabulary. The apex is the point or vertex furthest from the base of the object. So if you look over on the right, you can see that apex up there. It's written in light blue. That's the very top of the pyramid. Okay. The base is the bottom of the pyramid, whatever shape that is. So in Egypt, where all the pyramids are, most of the pyramids, I would say, I guess I don't know for sure, but most of them I feel like look like this picture that we have right here on the right. The bases are squares or rectangles, right? But we are going to see pyramids that have different shapes for bases, right? So we'll see when we get to the examples, but some might have triangle bases, some might have hexagonal bases, some could have octagonal bases, right? So this one, when you look to the right, that's like your typical pyramid that you think of when you think of a pyramid. But just so you know, they have different shapes for bases, and that's going to change a little bit how we find the lateral area and surface area of these. Then we have the height or the altitude. That's the perpendicular distance between the base and the apex. So you can see that red line over there that says height. That goes back to to the last chapter, right? Our height and our base are always going to be perpendicular to each other. Always going to be perpendicular to each other, okay? So same thing in here. Our height and our base will be perpendicular, because it's really important to distinguish that, because we also have something in pyramids called slant height, which is exactly how it sounds like. It's a slanted height, right? It's the diagonal distance from the apex to the edge of the base. So you can see over there on the diagram, that dark blue, the slant height just goes along the edge of the pyramid. It's a slanted height, okay? So that's some vocabulary for you. It's important that you know what the difference between like a height and a slant height, because you're going to need to plug things into the formulas in the correct way, okay? So here they are. Here is lateral area of a pyramid formula and surface area of a pyramid formula. So firstly, for the lateral area, it is 1/2 times the perimeter of the base times this little cursive L. That means that cursive L is slant height. Okay, so height is always going to be represented by H, like it always has been. Slant height is going to be represented by this little cursive L. Okay. And then surface area of a pyramid is just that lateral area plus the area of the base. Or in other words, if you would take this whole thing for a lateral area, that's what this is right here. So that's just another way of saying the exact same thing, right? Lateral area plus the area of the base. Remember that capital B means area of the base. Okay. So let's try some. So this first one, it's wanting us to find both the lateral area and the surface area of each pyramid. Let's do lateral area first, always, because then you need that lateral area to plug into the formula for surface area. Okay, so remember, lateral area. I always just start by writing the formulas because, I don't know, it's a good habit to get into. Lateral area is 1/2 the perimeter of the base times the slant height. So 1/2 the perimeter of the base. Well, you can see that that looks like a rectangle, but it's really a square since it's 10 and 10, right? That would mean all the sides are 10. So that would mean the perimeter of the base, 10 times 4, right, since there's 4 sides, would be 40. And then the slant height, you can see there, is that 13. It's this right here that's going along the edge, right? So that slant height is 13. So the lateral area, when you do 40 times 13 and then divide that by 2, that's 260 centimeters squared. Okay, and we have our lateral area. So let me write it here as well. 260 centimeters squared. Perfect. Now, let's do surface area. So we need that, remember, surface area surface area is the lateral area that we just found plus the area of the base. So we just found the lateral area is 260, and then the area of the base. That base that you see is a rectangle or square, like we talked about. So remember, to find the area of that base, when we're thinking of just that flat base, right, two-dimensional, you just do base times height, which would be 10 times 10, which is 100. So our surface area is 360 centimeters squared. So 360 centimeters squared. I wanted to remind you of something because I forgot to say this. Remember, lateral area is the area of all the faces except for the base, okay? So it makes sense that our first lateral area that we got is 260. That's all the sides of the pyramid and not the bottom, okay? And then when we wanted surface area, which means all of the sides, all of the faces area, right? It makes sense that we would just add 100 to that because we have just the base to add, which is 10 times 10, right? So remember, lateral area is all the sides without the base, and then surface area is everything. Sides, base, everything, okay? Let's move on to the next one. So here we have another pyramid. So the first one was just a regular pyramid. I'm gonna say the name of all these. Do you see the shape of this base is a triangle? Okay, so this would be something called triangular pyramid. Okay, because it's a pyramid, because it just has one bottom and then it has all the sides coming up to one point, the apex. But the base shape is a triangle, so it's a triangular pyramid. Okay, so let's find lateral area. Remember, oh my goodness, it is 1/2 perimeter of the base times the slant height. So 1/2, it tells us all three sides of that base are all 10, right? So the perimeter of that base would be 30. The slant height, it shows us right here, is 12. So the lateral area would be 30 times 12 divided by 2, which is 180 meters squared. So, lateral area, 180 meters squared. Okay? And then now we can find surface area. That is the lateral area we just found plus the area of the base. So, the lateral area was 180 plus, okay, so I'm just going to put capital B again for now because I want to kind of branch out from here and just show the work for this one actually. The area of the base, so this, we have to think about what's the shape of our base here. It's right here, right? That's an equilateral triangle. It tells us all three sides are 10, so that's an equilateral triangle. You have to recall from last chapter what the area of an equilateral triangle is. Hopefully you still have either that formula sheet or you still have your notes, right? Or you could Google it. The area of an equilateral triangle was this, remember? It's the side squared, square root 3 over 4. Okay, so this would be, again, it doesn't really matter if you type, I'm just going to type everything into the calculator because we're going to get a decimal in the end anyway. So 100 square root 3 divided by 4. This would be 43.30 if I rounded to the nearest hundredth. Okay, again, I'm not a stickler about rounding. Don't stress about the rounding part. Okay, it's did you know how to do the work correctly? So back to this over here. The surface area was 180 plus that area of the base we just found is 43.30. So roughly the surface area would be, when you add those together, 223.3 meters squared. Okay, so hold on, let me write this and then I'll 223.3 meters squared. The thing is that, so the only thing that really changes from problem to problem in like what formulas you're using is what shape is your base, right? The first one up here was just a rectangle or square base, so it was really easy just to remember base times height for that base. But then this base was equilateral triangle, so that's why I actually wrote it out in purple to show you you would have to use a different formula for that area of the base because it's a different shape for the base, right? Okay. If you want to stop, this next one is exactly, well, really close to what 1 is. So I would, if I were you, stop it here. Okay, if you want to let those first two examples process, stop it, let them process, and then try number 3 because, like I said, it's like number 1. So try it for yourself, and then you can watch to make sure you did it right. Okay. So, number 3. This, again, is just a regular old pyramid, right? It has a rectangular or square base, so it's just a pyramid. So lateral area for this one, remember, 1/2 perimeter of the base times the slant height, 1/2 the perimeter of the base. So it seems like all 4 sides would be 12 then, right? If you know that 2 of them are 12, then the other 2 would have to be 12 as well. So 12 times 4, right, because you want the perimeter of that base, would be 48. The slant height, it shows us right here, is 12. Oh, no, sorry, 10. Sorry, you can see that. It has a cursive L and it's 10. Okay. So 48 times 10, and then divide that by 2. That's 240 inches squared. So lateral area was 240 inches squared. Okay. And now we can do surface area. So it's that lateral area plus the area of the base. So we just found it was 240 plus then the area of that base, since it's a square, you just do 12 times 12, which is 144, equals 240 plus 144, 384 inches squared. Okay? And then, lastly, so basically I would always just be thinking about which type of pyramid we have here, right? Because when it gets to that part where you have to do area of the base, it's going to change. So if you look at this base, it has 6 sides, which hopefully you remember that means that's a hexagon. So this would be a hexagonal. Oh my goodness, why does that keep happening? Hexagonal pyramid, because the base is a hexagon. Okay, so lateral area 1/2 perimeter of the base times the slant height. Okay, the perimeter of this base, we have to assume this is a regular hexagon, which means if that one little side is 7, that means all 6 of the sides would be 7. So if you would want to know the perimeter of that hexagon, just do 7 times 6, and then that's 42. So the perimeter of that base is 42. The slant height, it shows us right here, is 25. So the lateral area, 42 times 25, and then divide that by 2, is 525. It doesn't give us units, so units squared. Okay? So 525 units squared. And then lastly, let's do the surface area for this. It's the lateral area plus the area of the base. So that is 525. Again, let me just leave it as B for now because I want to show you the work for this one actually. The area of this base, so hopefully you remember the area of the hexagon. Again, if not, look back in your notes. Look back in that chapter 9 folder on Schoology, look on Google, do something, right? The area of a hexagon is 6 times the side squared, square root 3 over 4, right? So the only thing that changes in that formula is what S is, and this time our side length is 7. So that's why I put 7 squared. So the area of that base, when you just type that all into your calculator, would be 127.31. And again, I know my students kind of stress about, should we type in the root 3 in the calculator? Should we not type the root 3 in? Just type it all in. We want to get decimals, so just go ahead and type everything in because it'll keep it less stressful for you. Okay? So now we know the surface area is 525 plus that area of the base we just found is 127.31. So 525 plus 127.31 would be 652.31. Again, we don't have units, so units squared. Sorry for the bad handwriting. I'm trying to go fast because these videos are so long. Okay. Okay, so that is it. Again, email us if you have any questions or message us on Schoology. There is no homework for today. We decided to kind of switch things up because we felt like it was kind of a lot of work. So all you had to do today is just watch this video and take down the notes. Tomorrow you will actually practice doing this stuff. Okay? So have a great day. Stay healthy.